Hello friends, this video on neural control and coordination part 10 is brought to you by examfear.com. No more fear from exam. Let us talk about the resting membrane potential. As I said, even when the neuron is resting, that is the neuron is not doing any work, even that time there is a potential difference which exists across the neuron, and that is known as the resting membrane potential. So first the question is, when is the neuron said to be in resting phase? When it is not being excited, that is, it is not conducting any impulse. For example, let us take a very common, a small example. Let us suppose somebody pinches you. Let us suppose you are sitting quietly on a chair. Somebody comes and pinches your hand. So when he pinches your hand, that is actually a stimulus. That is actually a change in the environment. So your skin is the receptor. The skin recognizes the touch, right? So that means the neurons which are present near the skin, they get excited because they receive some stimulus. But as long as nobody touched you, there was no stimulus, right? So that time the neuron was in resting phase. But the moment somebody touched you, the neurons got excited. So that means that time they are in the excited state. Clear? So whenever the neuron is in resting phase, that means it is not conducting any impulse. That is, that time also there is a potential difference, and that is known as the resting membrane potential. Okay, so normally what happens is, now when we talk about the exchange of ions, we are mainly going to talk about the potassium ions and the sodium ions. So these are the two ions whose exchange we are going to talk about in this concept of membrane potential. So that is one thing to be noted here. Okay, so now normally when the neuron is in the resting phase, normally it has been seen that inside the axon, the potential inside axon, the concentration of the potassium ion is high. That means there are many potassium ions inside the axon. Inside the axon means in the axoplasm. Whereas outside the axon, that means in the extracellular fluid, there the concentration of sodium ions is quite high. So outside axon would mean the extracellular fluid, inside axon would mean the axoplasm. So this is normally how the concentration of sodium and potassium ions is in a resting membrane potential initially. And also there are some proteins which are negatively charged, some phosphate ions, and these are all immobile, and they are also present inside the axon. So inside the axon, the concentration of potassium ions is high, and also there is large concentration of negatively charged proteins or phosphate ions. So all these things are present inside the axon. So you remember the structure of the membrane, neuron membrane, which we discussed just now. So this is your axolemma, so which is a bilipid structure, and outside the axolemma is the extracellular fluid, and on the other side is the axoplasm. And here you have your tunnel-like structure, which allow only selective ions to pass through it, right? So these are the ion channels. So basically here, so as per the rule which I have mentioned just now, what am I trying to say? I am trying to say that in the axoplasm, there is too much of potassium ions, and also there are too much of negatively charged proteins or negatively charged phosphate ions. Whereas in the extracellular fluid, there are too many sodium ions. So that is the initial scenario, initial setup scenario. Now what happens? Due to the presence of the ion channels. Now here we did not talk about the ion channels, but we know that there are specific ion channels also present, and they are selectively permeable to specific ions. So let us discuss the ion channels which are present in the axolemma. So the first channel we'll talk about is the potassium channels. So what are these potassium channels? They are passive channels. What is the meaning of passive channels? Passive channels are those channels which are always open. That is, they always allow ions to pass through them, but the ions can pass only along the concentration gradient. So these channels are always open, but they allow ion exchange along concentration gradient. That means they allow ions to move only from region of high concentration to region of low concentration. Now, since it is potassium channels, that means it allows the flow of potassium ions. So they are selectively permeable only to potassium ions. They allow potassium ions to pass through them from region of high concentration towards region of low concentration. That is what we understand, right? So they allow potassium leakage along concentration gradient. So from high concentration to low concentration. Now in the previous slide, I told you that the concentration of potassium is high inside the axon. Now let me draw here. Let us suppose this is the membrane and these are the ion channels. Let us suppose these are my potassium ion channels, and this is the extracellular fluid where the concentration of sodium is high, and this is the axoplasm where the concentration of potassium is high, right? And let us suppose this is the potassium channel. So this potassium channel is a passive channel, so it will be always open, always it will allow potassium to pass through it. But it will allow it to pass only from region of high concentration towards region of low concentration. So it will allow potassium only to move from inside to outside. So potassium can move only in this direction. And there can be multiple potassium channels like this. It is not necessary that there will be only one potassium channels. There can be multiple potassium channels like this, and they all will allow potassium ions to move from axoplasm to the extracellular fluid. So that is the potassium channel. Let us now talk about the next channel, that is the sodium channel. So now these sodium channels are also passive channels, that is they are also open all the time, but they allow, as the name suggests, they allow the passage of sodium ions. So they allow sodium ions leakage along concentration gradient. So these are going to be the sodium channels. Now these sodium channels will allow sodium to move from high concentration towards low concentration. So it will allow sodium to move from outside to inside, right? Now, so as a result, what will happen? The potassium ions will keep moving outside and the sodium ions will keep moving inside. So what will be the result of that? Now a very important question is, are the number of sodium channels and the number of potassium channels the same? If there are 10 sodium channels, are there 10 potassium channels also? Because in that case it will get balanced. The number of positive charges moving out will become equal to the number of positive charges coming in, right? Because both of them are positively charged. Sodium is also positively charged, potassium is also positively charged. But it has been observed that the number of potassium channels, is greater than the number of sodium channels. So what does that mean? That means there are more red channels than the green channels. So in this example, in this picture, you can see that if there are 2 potassium channels, that means there are 2 potassium going out, but there is only 1 sodium channel. So there is only 1 sodium coming in. That means more potassium will go out and less sodium will come in, right? So what would be the result of this? The result would be more potassium will go out, comparatively less sodium will come in. So as a result, what will happen? Now as a result, inside, if you look at the inside of the membrane, inside of the membrane is this axoplasm region. Now what will the axoplasm contain? Axoplasm anyways had the negative charges, you remember, which were immobile. So these negative charges cannot go anywhere. So inside we have the negative charges and we have some sodium ions which are coming in and some potassium ions also which are currently going out. And if you look at the outside, what do you have? Outside you have all positive things, the potassium ions which are flowing out and some sodium ions also, right? So overall, if you see, inside is negative when compared to the outside as of now. But I have not yet completed my discussion. So right now we have only discussed about two type of channels, that is the potassium channels and the sodium channels. And after discussing these two channels, we feel that the inside of the membrane is more negative when compared to the outside of the membrane. So that is our conclusion so far. But we are yet to discuss about a special type of channel. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.